Hey, my name is Jesus Castillo, and in this video, you're going to learn about data structures in Ruby. What is a data structure? A data structure is a way to collect data and work with that data. For example, an array is a data structure. You can have multiple items, multiple elements in the data structure, and then you can iterate, you can loop over all of the elements. That's a data structure. Another data structure that you might be familiar with is the hash. The hash maps keys to values, and that is another data structure. Other data structures include the set, the stack, the queue, binary trees, prefix trees, all kinds of data structures that are available to you. Why are data structures important? Data structures are very important and very useful because depending on which data structure you choose, your code is going to be more efficient, faster, or slower. So if you choose the right data structure, it's like choosing the right tool for the job. It will be faster, and it will also allow you to create and write better code when you use the right data structure. And if you don't use the right data structure, you will have to be working around it and doing things that are not very efficient and that don't produce good code. So as you can see, choosing the right data structure is very important. Now, how do you choose the right data structure? Well, you need to be familiar with the different kinds of data structures, and you need to be familiar with each data structure's use cases. So each data structure has some best use cases, and it has some performance characteristics that you need to know. And to give you a concrete and direct example of this, we're going to be doing an example here. So I have this URL, it's just a string. And what I want to do for this demonstration is to count the characters. I want to count the characters in this string. So for example, we have 2 U's, as you can see there. And every other character is only there once. So we want to produce some kind of result, some kind of output that gives us the count of these characters. And to do that, we're going to need to store in some way these counts, right? We need to say, hey, there are 2 U's, there is 1 Y, there is 1 G, there is 1 D, right? And in my first implementation, I'm using arrays to do this. So I have this count array, empty array to start with, and we return it at the end with the count of the characters. Next, we have this loop, and this loop is using each char. So each char is a string method that goes over each character of the string, and then it allows you to work with that character, do something with that character. That's what we want to do. So I'm using each char, and inside the each char block, what I'm doing is trying to find if we already found this character. So I'm looking in counts, and I'm finding the character pair. So what I'm doing to understand this, you need to understand how I'm saving the count. So what I'm doing is I have this array, and then I have subarrays inside it, and they look like this. They look like character, for example, the character A, and the count, how many times we found this character inside the string. So for example, 1. And what we will have at the end of this algorithm, at the end of this program, or this method, is an array of arrays or multidimensional arrays where each of the superarrays has the characters and its count. So what I'm doing here in this if statement is if we already started counting, meaning if you already started counting, meaning that we are found if we already started counting, meaning that we already found here, we found the character count inside the counts array, then we add 1 to it, plus 1, plus equals 1 to the character count. And this index 1 because index 1 it has the count and index 0 is the character itself. Else, we create this subarray. We create a subarray where the first element is the character, the second element is the count starting at 1. So that's how this is working. It's going over each character and then it's trying to find the subarray and then it's adding the counts. And we can see that this works. I'm going to use pp for pretty print. And we can see this working correctly, right? We get the 2 U's as expected and everything else, there is only 1 character. Now the problem with this is that it's not the most efficient, it's not the best way to do this, it's not the fastest. And the reason for that is that we are not using the right data structure. You will notice that we're mapping values to other values. We're taking the character and we're taking the count and they go together, right? So this is a mapping of 2 values. But the better way to do this is to use a hash, because a hash is specifically built to map values to values. We wrote another method that does the same thing, it counts the characters. And as you can see here, it's only 1 line of code. 1 line of code. This line of code does all of that. So that alone is already better. We will see in a moment it's also faster in terms of performance. So let's go over this code. First we do chars. Chars, it breaks down the string into characters. Then we do each with object. So if we each with object allows you to create an object and then use this object as some kind of accumulator object. So what we are accumulating is the character counts. And as you can see here, I'm using the character as the key of this hash. And we are doing plus equals 1. So we are counting the characters this way. And as you can see, the output is here and it's the same, it's working, right? And now let me show you the benchmark I wrote for you so we can actually compare the performance of these 2 approaches. Okay, so here's the benchmark. I'm going to run it for you. And we have the results. As you can see here in the right, the hash is a lot faster than the array. The hash is more than 2 times faster than the array. So that's yet another reason that a hash is the best data structure for this use case. So every time that you want to map one value to another value and do things like counting, then the hash is the right tool for the job, is the best choice. So I hope this example, this demonstration helps you see why data structures and choosing the right data structure is so important. And what I want to do for you is record a few more videos like this, where I show you other data structures that you can use and their specific advantage and the specific uses where you can use these data structures to make your code faster and better and easier to read, easier to work with. Okay, so I'm going to be releasing these videos soon, so keep an eye for them. So I hope you look forward for these videos. And if you like this video, this introduction to data structures, please give me a like so that I know that you like this video, and I will keep making more videos like this for you. Thanks all for watching. See you in the next video.